NEC Section 250.148 mandates that the ground path must remain continuous even when a device is removed. It's important to note that this section does not dictate a specific type of connector for achieving this. When considering wire nuts for ground wire splicing, the NEC does not explicitly approve their use, but it also does not explicitly forbid it. Generally, using wire nuts is seen as compliant with Section 250.148 if certain criteria are met. Firstly, the wire nuts must be appropriately sized for the gauge and the number of wires being spliced. Secondly, they should be listed specifically for use in grounding applications. Thirdly, they must establish a secure and lasting connection that won't break during regular operation. Fourthly, they must be installed in a way that does not disrupt the integrity of the ground path. An inspector's preference for barrel crimps or green wire nuts might stem from their individual judgment or local interpretations of the code. While these alternatives can offer extra confidence in the security of the connection, they are not the only methods that comply with the code. Splicing ground wires using red, yellow, and tan wire nuts represents a widespread practice within the industry. Inspectors have routinely accepted this practice for many years without raising concerns. If there is any uncertainty regarding whether wire nuts are acceptable for splicing ground wires in a particular area, it is always advisable to consult with the local building inspector to clarify the local requirements. In many cases, the inspector's demand isn't rooted in a specific code infringement. In such situations, the electrician can politely inform the inspector that they believe their use of wire nuts adheres to Section 250.148a. It can be helpful to provide documentation that supports the electrician's position, such as the listing details for the specific wire nuts they are using. Let's delve into the specifics of NEC Section 250.148, which addresses the continuity and integrity of grounding paths. The core principle of 250.148 is to ensure that the equipment grounding conductor, often referred to as the EGC, remains intact even when a device is removed from the circuit. This is crucial for maintaining a safe and effective path for fault current, which is essential for the proper operation of overcurrent protective devices like circuit breakers and fuses. The code doesn't specify the exact type of connector or method that must be used to achieve this continuity. Instead, it focuses on the functional outcome, the uninterrupted grounding path. This flexibility allows for various connection methods as long as they meet the overarching safety and performance requirements. Now let's consider the role of wire nuts in this context. Wire nuts, also known as twist-on wire connectors, are a common and convenient way to join electrical wires. They consist of a plastic or thermoplastic shell with a conical metal insert. When the wires are twisted together inside the wire nut, the metal insert creates a secure mechanical and electrical connection. The code does not explicitly prohibit the use of wire nuts for splicing ground wires. However, their acceptability hinges on meeting certain conditions that ensure a reliable and safe grounding path. One critical factor is the proper sizing of the wire nut. Wire nuts are designed to accommodate a specific range of wire gauges and numbers of conductors. Using an undersized wire nut can result in a loose or incomplete connection, which can increase resistance and potentially lead to overheating or arcing under fault conditions. Conversely, using an oversized wire nut can also be problematic, as it may not provide sufficient pressure to create a secure connection. Manufacturers provide clear guidelines on the appropriate wire combinations for each wire nut model, and these guidelines should be strictly followed. Another important consideration is whether the wire nut is listed for use in grounding applications. Some wire nuts are specifically designed and tested for grounding purposes, and these are typically identified with a green color or markings indicating their suitability for grounding. These listed wire nuts have undergone rigorous testing to ensure that they can withstand the mechanical stresses, environmental conditions, and electrical fault currents associated with grounding systems. Using a wire nut that is not listed for grounding applications could compromise the integrity of the grounding path and increase the risk of electrical hazards. The security and permanence of the connection are also paramount. A grounding connection must be able to withstand the vibrations, temperature changes, and mechanical stresses that are commonly encountered in electrical systems. A loose or poorly made connection can degrade over time, leading to increased resistance, voltage drop, and potential failure. Therefore, it's essential to ensure that the wires are properly stripped, twisted together tightly, and securely seated within the wire nut. The wire nut should also be installed in a way that prevents it from loosening or backing off over time. Finally, the installation of the wire nut must not interfere with the ground path. This means that the wire nut should be installed in a location where it is protected from physical damage, moisture, and other environmental factors that could compromise its integrity. The wire nut should also be installed in a way that allows for easy inspection and maintenance. For example, it should not be buried behind walls or ceilings where it is inaccessible. Now, let's address the inspector's preference for barrel crimps or green wire nuts. Electrical inspectors play a vital role in ensuring the safety and code compliance of electrical installations. They are responsible for interpreting and enforcing the NEC and other applicable codes and standards. Inspectors may have their own preferences or interpretations regarding the best methods for achieving code compliance. These preferences may be based on their experience, training, or local code amendments. While an inspector's preference for barrel crimps or green wire nuts may not be explicitly mandated by the NEC, it is important to respect their judgment and address their concerns. Barrel crimps are a type of compression connector that provides a very secure and reliable connection. They consist of a metal sleeve that is crimped onto the wires using a specialized crimping tool. Barrel crimps are often used in critical grounding applications where a high degree of reliability is required. Green wire nuts, as mentioned earlier, are specifically listed for grounding applications and provide an additional level of assurance. The use of red, yellow, and tan wire nuts for ground wire splicing is a common practice in the electrical industry. These wire nuts are typically used for general-purpose splicing of insulated conductors, but they can also be used for grounding applications if they meet the requirements outlined earlier. The acceptability of using red, yellow, and tan wire nuts for grounding may vary depending on the local jurisdiction and the inspector's interpretation of the code. If there is any doubt, it is always best to consult with the local building inspector to clarify the requirements. If there is uncertainty about the acceptability of wire nuts for ground wire splicing in a specific area, it is advisable to consult with a local building inspector. The inspector can provide guidance on the local code requirements and any specific interpretations that may apply. In some cases, the inspector may require the use of alternative methods, such as barrel crimps or green wire nuts. If the inspector's requirement is not based on a specific code violation, it may be possible to respectfully discuss the issue with them and provide evidence to support the argument that the use of wire nuts is compliant with Section 250.148a. This evidence could include the listing information for the wire nuts being used, as well as documentation from reputable sources such as electrical engineering handbooks or industry standards. Understanding the specific requirements outlined in NEC Section 250.148 is crucial for ensuring the safety and compliance of electrical installations. While the code does not explicitly prohibit the use of wire nuts for ground wire splicing, it is essential to ensure that they meet certain conditions to provide a secure and reliable grounding path. Consulting with local building inspectors and providing documentation to support code compliance can help resolve any disagreements and ensure a safe and code-compliant installation. The primary goal of equipment grounding is to provide a low-impedance path for fault current to return to the source, allowing overcurrent protection devices to quickly clear the fault and prevent electrical shock hazards. A continuous and reliable grounding path is essential for achieving this goal. NEC Section 250.148 specifically addresses the situation where a device is removed from a circuit. In this scenario, it is critical that the equipment grounding conductor remains intact to ensure that the grounding path is not interrupted. This is typically achieved by splicing the grounding conductors together using a method that provides a secure and permanent connection. Wire nuts, barrel crimps, and other listed connectors are commonly used for this purpose. The key requirement is that the connection must be able to withstand the mechanical stresses, environmental conditions, and electrical fault currents that may be encountered in the electrical system. In addition to meeting the requirements of Section 250.148a, it is also important to comply with other relevant sections of the NEC, such as 110.3b, which requires that all equipment be installed and used in accordance with its listing and labeling. This means that the wire nuts or other connectors used for grounding must be listed for the specific application and must be installed according to the manufacturer's instructions. It is also important to ensure that the grounding conductors are properly sized according to NEC Table 250.122. The size of the grounding conductor must be adequate to carry the available fault current without overheating or melting. In general, the grounding conductor should be the same size as the ungrounded conductors in the circuit. However, in some cases, a larger grounding conductor may be required. Grounding is fundamental to electrical safety, and understanding the nuances of code requirements, industry practices, and inspector interpretations is crucial for electrical professionals. While the NEC provides a framework for safe electrical installations, local interpretations and individual preferences can sometimes create confusion. Open communication, a commitment to code compliance, and a focus on safety are key to navigating these situations successfully.